Conventional recommender systems are roughly categorized into collaborative filtering and content-based filtering. Collaborative filtering recommends musical pieces by taking into account how someone else has rated them. Although this approach has been used in many e-commerce services, it often makes uninteresting recommendations. Content-based filtering recommends musical pieces by automatically analyzing the contents of music without the need of the rating system, but the accuracy of making recommendations is limited. Therefore, we proposed a hybrid music recommender system that combines the merits of both approaches. Let us see an example of the hybrid music recommendation system. For example, we will try to make recommendations to this Amuro Namie fan who likes these two pieces. Collaborative filtering recommends familiar songs in the top 5 rankings. BoA songs are recommended after top 5 rankings. Content-based filtering also does not highly recommend BoA songs whose moods match the user's musical taste. Hybrid filtering can make a more accurate recommendation including both Amuro Namie and BoA songs. We assume that users select genres and then take into account the ratings and the contents of musical pieces when they listen to music. An effective modeling of this process results in the high accuracy of this recommendation system. In the future, we will try to develop a system that can efficiently handle several million pieces and users. To find a song that has the desired singing voice from a large music database, the vocal finder can do this time-consuming task automatically. Because we thought it would be more convenient if we could retrieve songs using a singing voice as a query, we developed this system named Vocal Finder. Our method can extract features that express characteristics of a singing voice from musical audio signals containing both the singing voice and accompaniment sounds, and this method enables our system to retrieve users' favorite songs. The Vocal Finder makes it easier to discover a new favorite song that you hadn't known before. Our research aims at exploring and achieving future music listening with more active and deeper experiences. Toward this goal, I propose new approaches in 3 domains: music playback, music customization, and music discovery. For example, first, for music playback, our research enables a user to skip sections of no interest to jump to and listen from the chorus section, or click on a word in the lyrics shown on a screen to jump to and listen from that word. Second, for music customization, our research enables a novice user to personalize available music recordings by easily changing the volume and timbre of sounds of recorded musical instruments, such as drum sounds. Third, for music discovery, our research enables a user to find songs having favorite vocal timbres, or we can build a system that infers users' musical taste and recommends interesting songs. I named the series of these approaches active music listening interfaces, and we will lead this research in various ways. Musical Instrument Equalizer is a novel musical audio player. Users can listen to musical pieces by changing the loudness of each musical instrument part and not the frequency bands. Musical Instrument Equalizer accommodates users' music listening needs, such as changing the mood of musical pieces and listening only to a specific musical instrument. For instance, users can arrange their favorite pieces into a rock style by boosting the guitar and the drums, or into a ballad style by boosting the piano and the vocals. The novelty of this research is in the use of a sound source separation method, by integrating the harmonic and inharmonic structures to represent all musical instrument sounds. Next, we plan to incorporate this technology for a musical instrument karaoke system and a music retrieval system. We will introduce a music player with a unique technology, Sound Palette, which can replace the timbre of each musical instrument part by painting using color brushes. Since we can think of changing the timbre of a musical instrument as using a different color palette, I call this system as Sound Palette. Although there are conventional methods that manipulate pitch and duration of musical instrument sounds, the synthesized sounds using these methods are different from the sounds excited by real musical instruments, as these methods do not consider timbral characteristics. We constructed a mathematical model based on psychoacoustics so that it incorporates timbral characteristics. As a musical category, I love metal music. My dream is to convert all of music with metal timbre so that everybody will enjoy more metal music.